Okay, this is the Target 12E Permutations and Combinations Retake video. So remember the formula for a permutation, sorry, I'll write them up here. I think the formula for permutation and choose R is n factorial over n minus r factorial. And the combination, n choose R, is n factorial over r factorial and then n minus r factorial. Okay, and remember factorial means that you multiply all the numbers starting with whatever n is all the way down to 1. So if you're doing 5 factorial, you do 5 times 4 times 8 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so the permutation of 7 factorial choose 4 would be 7 factorial over 7 minus 4 factorial. So this is 7 factorial over 3 factorial. And 7 factorial is 7 all the way down to 1. And 3 factorial is 3 down to 1. And you know what? I'm going to write these over here so they'll cancel nicely for us. So notice the 3's are going to cancel, the 2's are going to cancel, and the 1's are going to cancel. So my answer is just going to be 7 times 6, which is 42, times 5 times 4, which is 20, and 42 times 20 should be 480. But I'm just going to double check. Okay, 840. So if you have a TI calculator, you can double check this by using the permutation button. And to do that, you go to Math, and then arrow over to Probability, and then go down until you get to the permutation. Whoops, I forgot. You have to type in 7 first, then Math, then all the way over to Probability, and then down to Permutations. Select that, then hit 4, because I'm choosing 4, and then hit Enter. On Desmos, those of you that downloaded Desmos, you can go to your stats, you go to your functions, and then go to stats functions, and then there's NCR and NPR at the bottom. You're going to type NPR, and it gives you a parenthesis with some commas in between it, and you can put in 7, and then the 4, and it gives you 840. Which is the answer we got doing it the other way. Okay. Now you have to do it this way. You have to show the work. You can use the button on your calculator if you know how to use it to double check it. But you have to show this work or you will get it incorrect. So for, and I just wanted to let you know, since I was dividing by 3, 2, 1, I could have just gotten away with writing 7 times 6 times 5 times 4, and I didn't need to write all that out. Because that's kind of confusing for some people, I'm going to go ahead and write it, but you don't have to write everything. So again, the combination of 8 choose 5 is going to be 8 factorial over 5 factorial, and then 8 minus 5 factorial. So this is going to be 8 factorial over 5 factorial over 3 factorial. Now, you'll notice that we have 5 factorial. So I really only need to write...
Hello, anyone home? So I can hear you.
Okay, so 8 factorial is 8 all the way down to 1. And 5 factorial is 5 all the way down to 1. So I could have gotten away with just writing 8, 7, 6 on top, and then the 3, 2, 1 for 3 factorial on the bottom. Because these are always going to cancel. But if I write them all, that's okay. So then I can either multiply straight across if I want, or I can go ahead and do some canceling. I'm going to cancel. You might notice that 3 times 2 is just 6. So all of that on the bottom cancels with that 6 on top, and I'm left with just 56. And then again, I can use the button on my calculator. This time, if I have the graphing calculator, the TI graphing calculator, I can go to Math, no, first I have to type in 8. So 8, then math, then arrow over to probability, and then choose the NCR button, hit enter, and then choose 5. And again, on Desmos, you go to the function button, stats, the NCR button, and then you type in 8, and then 5, it's separated by comma, and you get 56. But again, you have to show all this work. Okay, list all 2-letter permutations for the word smile. So, permutation order doesn't matter, or order does matter. So that means SM and MS are 2 different entries. So I'm going to say S with the M, S with the I, S with the L, and S with the E. Then I'd say M with the S. Now remember, SM and MS are 2 different entries, so I need to have both of them. Then M with the I, and then M with the L, and M with the E. Okay, and then I with the S, I with the M, I with the L, and I with the E. And then L with the S, L with the M, L with the I, and L with the E. And then finally, E with the S, E with the M, E with the I, and E with the L. Okay, so this is the list of permutations, and then here's how we can check it. Remember, permutations order doesn't matter, or sorry, order does matter. So it's a permutation, there are 5 letters, and we're choosing 2. So this is 5 factorial over 3 factorial. But again, this is just to check that we have the right amount. It isn't to check to see if they're all right or even the answer. This right here is the answer. But if you notice, there are 20 of them, and the permutation 5 choose 2 is 20. Now I want you to look at this. In a permutation, S first and then M, and M first and then N, or sorry, S first and then M is different than M first and then S in a permutation because order matters. Now in a combination, order doesn't matter, so SM and MS count as one single problem. So I'm going to write SM, SI, SL, and SE. Now I'm not going to write MS again because I already have SM. Now I don't have MI on this list, so I'm going to add MI, ML, and ME. But look at this. This is IS, and I already have SI. So I'm not going to write IS. And then this is IM, but I already have MI, so I'm not going to write IM. Then I have IL and IE. Okay, and then LS is SL, LM is ML, and LI is IL, so it looks like the only thing left is LE. And LE isn't down here, so I'm going to add LE. Okay, then ES is SE, we already have it. EM is ME, we already have it. EI is the same as IE, we already have it. And EL is the same as LE. These are too sloppy for me to read. This is IE. And LE. Alright, let's just rewrite the E. There, LE. Now, if you notice, this is a combination, order doesn't matter. So 5 choose 2, 5 factorial, 3 factorial, and 2 factorial. So 5, 4, 3, 2, 1, 3, 2, 1, and the 2, 1. So I get 20 divided by 2, which is 10. And if you notice, if you count those up there, 10, 4, 8, and 2 is 10. Okay, number 3. We're setting a 6-digit alarm code for our home alarm. You can use numbers 0 to 9. So how many numbers are there from 0 to 9? 0 to 9 is actually 10 numbers. Okay, 1 through 9 is 9 numbers, and then 0 would be the 10th number. Okay, so there's 10 numbers. Numbers can't be repeated. How many different codes can you make? So for an alarm code, order matters. So it's a permutation. And remember, the formula for a permutation is NR is n factorial over n minus r factorial. So we have the permutation of 10 to 6. So this would be 10 factorial over 10 minus 6 factorial. So 10 factorial over 4 factorial. So it'd be 10, 9, 8 all the way down to 1. And then 4 all the way down to 1. And these cancel. So it's 10 times 9 times 8 times 7 times 6 times 5. So I'm going to do that on my calculator. 10 times 9 times 8 times 7 times 6 times 5. And I get 151,200. Okay, so most of you have alarm code keys, and you know what's interesting is now they want you to have caps, they want you to have letters, numbers, a capital letter, a lowercase letter, and then one of the ASCII keys, like the @ symbol or the number symbol or something. So if we just did all the numbers, that's 10. So there's 10 choices just for numbers, and then you can have repeats, so it would be 10. Then there's 26 for lowercase letters, 26 for uppercase letters, and then I don't even know how many ASCII keys. But the combination for those is amazing, and that's what makes passwords really hard to break, unless you use something personal, like your name or something. Okay. Let's try number 4. So your friends go to stop for pizza. They have 7 toppings. You want 4. How many options do you have? Is this a combination or permutation? And it's a combination because it doesn't matter what order the toppings are put on a pizza, right? Okay, and this would be the combination. N choose R, remember, is n factorial, r factorial, and then n minus r factorial. So the combination of 7 choose 4 is 7 factorial over 4 factorial, and then 7 minus 4 factorial. So 7 factorial, 4 factorial, and 3 factorial. So 7, 6, 5, 4, 3, 2, 1, and I need to put a 4 factorial on the bottom and a 3 factorial. So the 4 factorials cancel, and I'm left with 3 times 2 is 6, that cancels with that 6, so 7 times 5 is 35. Okay? So the following problems have to be done on your own. You need to show them either to your math teacher, your geometry support teacher, or math lab teacher. So here we're doing a permutation and combination. Here we're rearranging or writing all the different ways we could write the letters. Here another alarm code. This is interesting. This is using letters. Remember, there's 26 letters in the alphabet. And you get a cold stone for ice cream. There's 29 mix-ins. You know, I actually looked it up, and there are 29 mix-ins. All right.